then what will be the position of ahead? Any idea? Ahead means just one position before the front. So if this is your front, if this is 1, 2, 3, 4 and 5, let this is your double-ended queue and this is your front. Okay. If front is 1, then what will be the previous previous sales index will be the last one. So this will be your ahead. Is it clear? Why? Because it looks like a, so this is 1 and this is 2, this is your 3, 4 and this is 5. Let this is 5. So if this is the front, this is the front and we are we are insert there will be a insertion operation at the front. Generally front is used for deletion, that is you have to advance your front in a clockwise direction in case of circular array and you will be able to delete a item. So this is the deletion, but here you have to advance your front in a counterclockwise direction. So if this is your front, so front is at 1. Okay. So what will be the value of ahead? Ahead is just a position before the front. So what will be the ahead? Ahead will be at this position. Okay. Number 5. So this is your total length. If this is your length, if this is your length, then if front is 1, then what is the position of ahead? As we are using the circular queue, we are using the circular array, so the position of the ahead is at this position, that is length. So that's why Shourashish, if front is equal to 1, that is your front is at extreme left. Okay, is it clear?
Yes, sir, got it.
Then your ahead pointer is pointing at the length. Otherwise that is your front is at extreme right or your DQ is empty. Okay. Or there may be a intermediate position. Your front is at extreme right or DQ empty, or there is a intermediate position. So if your front is the length, if your front is the length, then line number 4, if your front is equal to length, that is if this is your new front position, let this is your new front position. Okay, then what will be the value of ahead?
So ahead should be the previous one.
So ahead should be the previous one. So you are using, so this is your so this is your front. So this is your front. So your ahead is just one before.
So this is one after. No?
In case of
Uh,
this is clockwise direction. Okay.
Sir, earlier we were going anti-clockwise. Why are we going clockwise in this case?
So this should be front minus one. Is it
Yeah.
front minus one?
Yeah, but then we can't keep the front equals to 0 part here. For
Yes.
front equals to 0, it ahead will be 1. But for front equals to length, it should be length minus 1. No?
Actually, this is the rule. If front is at your last position, then you have to take the ahead at the first position. And if this is the normal case, front is equal to 0th position, then your ahead starts from the first position. Okay. So these are basically normal rules from line 1 to line 5. And this is your intermediate position, line 6 and 7. That is, if your front is at this position, then your ahead is at this position, just one before.
So, sir, everywhere we are going counterclockwise, but only in this case we are going clockwise. Why is this?
So according to you, this should be for
Say
from.
front equals to length condition shouldn't be there. That's it. I think it will work then. Maybe.
If front is equal to 1, if front is equal to length, then the next position, next means previous position, actually ahead position, the ahead position of front is 1. So front is equal to length means you are at the right, extreme right.
Yeah.
You are at the extreme right. So here just we use this particular condition that your next pointer, that is your ahead pointer, is at 1, position number 1, index number 1. Okay.
Yeah, I got that, but why are we going clockwise in this case only?
Okay, you can if 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 front is equal to length, if front is equal to length, if front is equal to length, then if front is equal to length, then
Ahead equals to length minus 1.
ahead is equal to length minus 1. Else
Sir, like I think if we put if front equals to 0, then ahead equals to 1, and in the else part will cover this condition also.
so this is redundant, line number 4 and 5.
Yes, yes, sir. Line number 4 and 5 were redundant. The
Just
else
a minute.
part will always cover this one also.
So if, is it right?
Yes,
If
sir.
front is equal to 0, then ahead is equal to 1. Okay. And otherwise, your ahead is front minus 1. That is, your front is intermediate position and and is at extreme right. So your DQ is empty. Is it clear?
Yes, sir.
If your front is 0, then ahead is equal to 1. Otherwise, your ahead is front minus 1. And if your ahead is rear, then if your ahead is at rear,
Then overflow.
then your queue is total full. Queue is full. Queue is full. So your queue is full and print the overflow. Otherwise, just copy this ahead in the front and item is copied at the ahead part. Is it clear? Line number 12 and 13. You have to copy the ahead, that is, uh, suppose this is your front. Suppose this is your front, okay? Front is at 1, position number 1. Then your ahead should be at this position. This position is your ahead, right? Now your front is used for insertion. So your next front will be, so cross this front, and your next front will be at this position F, and insert the value 5. So front is used for insertion. Is it clear? So this is the push DQ function. Any queries?
No, sir.
And what will be the eject function? That is deletion from the rear. This is the deletion from the rear. How to delete? Any idea? Anyone?
So here we will be checking the rear portion everywhere.
So from the rear, actually rear is used for insertion. We have to advance the rear and we have to put the value at the rear position, new position, okay? But when rear is used for deletion, then if your front is 0, then total underflow. Your queue is totally empty, okay? If your front is at rear position, then if your front is at rear position means
Only one element.
only one element will be there, then just copy the element at the item and initialize front and rear with 0, 0 or -1 depending upon your starting index. Otherwise, else part, at the else part, when rear is 1, that is rear is 1 means actually 1 is your starting index, okay? So rear is 1 means your rear is at the left part. So your rear, so this is your, suppose this is your rear. So rear is at the left position, extreme left, okay? So you have to delete from the rear. Now you have to delete from the rear. How to delete from the rear? So just copy the rear portion at the item, okay? And your length now becomes the rear. Chodashish, can you explain these two lines, line number from 8 to 10?
Yes, sir. So since rear is at the first position of the array, so
Yes.
when we delete that, obviously the rear will go one before. So we will move counterclockwise, and while moving counterclockwise, the next, the actually the previous pointer will be length.
Will
So
be your length.
yes.
Otherwise part, line number 11, 11 to 12, that is your rear will not be
Eh,
the extreme left. That is your rear is at either extreme right or any intermediate position, okay? So
yeah.
intermediate position, okay, intermediate position. Then if your rear is at extreme right, then
Then, so here also it's the same thing again. We are moving clockwise in this case again. I don't know why. We should be
so
moving counterclockwise again.
okay, so how to modify these lines? Line number 12 to line number 14.
Sir, actually, line number 12 to line number 17 all will come under only one condition: rear is at any intermediate position.
So
Just an else and everything. This item equals to DQ rear.
is it
Yes,
right?
after line number 11, it should be 16 and 17, I think.
Line
The
number
other 12, 13, 14, 15 are not necessary.
so if so other part, that is else part, uh, this is the, it contains single element, okay? So extreme left. So your rear is at extreme left. So otherwise means rear is at any intermediate position. So rear will be now at any intermediate position. So then copy the rear and decrement the value of rear. Okay. Now is it clear? The algorithm how to insert how to delete from the rear end.
Yes, sir.
This is the simple case. Now there will be two double-ended queues, two variants of the double-ended queue. First one is the input restricted double-ended queue. So input restricted double-ended queue and output restricted double-ended queue. What is input restricted double-ended queue? Any idea? Input restricted?
So probably input will be only from the rear end.
So
Yes.
deletion will be performed at both ends, but insertion can be done in only one end.
Yes. So input restricted means this is your queue. Okay. So this is the queue and this is your front. This is your front and this is your rear. Okay. So input restricted means input is always restricted and rear is used for rear is used for insertion. So insertion at the uh, that is input is restricted at the rear end also only rear end only. So this is the insertion, but as this is a double-ended queue, deletion can be done at the rear end as well as this is the normal case from the front end. So this is the input restricted. Okay. Output restricted. What is output restricted? That is deletion is restricted. Deletion can be done only from its normal way. That is deletion is used for deletion we have to use the front one also only. So this is the front and this is the rear part. So output restricted. So output restricted means so this is used only for your deletion. Okay. But the front can be used for insertion and this is the normal case that is rear is used for the sorry uh, rear is used here rear is used for insertion. Okay. Is it clear? So this is the output restricted and this is the input restricted. Is it clear to you? So these are two variants of the double-ended queue, input restricted and output restricted. Now priority queue. Up to this, any query?
No, sir.
No, sir.
Okay. So priority queue. So what is priority queue? Every element in the queue is associated. Every element in the queue is associated with a priority. That's why this is called the priority queue. So a priority queue does not strictly follow the first in first out principle. Okay. So this is your priority queue. Let a priority queue can be implemented in many ways. So let this is A, this is your B, C, let this is the intermediate positions. That's why we are using the dots. So let this is another position P, and let this is your X, and this is intermediate position. Let this is your front. This is your front, and let this is your rear. So front starts from A, and intermediate position is X. Intermediate position is denoted as X. Okay. Now every element of the queue is associated with a priority. So this is P1. Let this is priority number 1. Let this is priority number 2. Priority number this is 3. Let this is priority number 3. And there will be intermediate position. This is let priority number I. This is the intermediate position, and let this is priority number N. Okay. So this is the intermediate position. So value X. So value X is associated with a priority Pi. Okay. So with this structure, here the element X with a priority Pi. Here the element is X, and with the priority Pi, this can be deleted or this can be inserted just depending upon the priority value Pi. It will not use the first in first out structure. Okay. So priority queue can be used in just using a array. We can use a simple array. Okay, we can use just a simple array, or we can use a circular array. Okay, we can use multi-queue implementation. We can use a multi-queue implementation. We can use a double-ended queue. Okay, we can use a heap structure, heap tree. We can use a heap. So priority queue can be structured in simple array, can be structured in simple array or circular array, multi-queue implementation, double-ended queue. We can use the double-ended queue, or we can use the heap also, heap structure. We will discuss the heap in our 3 classes. So how to implement the priority queue? How to implement the priority queue using a double-ended queue? I will show how to implement the priority queue using double-ended queue, but simple array, multi-queue implementation, and heap, these are your assignments. Okay. So double-ended queue. So how to implement the double-ended queue?
Sir,
Yes.
don't actually know how to use heap.
Okay. So Just simple array or circular array and multi-queue implementation. These are your assignments. Okay. I will show 3 and 4. Priority queue using heap and priority queue using the double-ended queue. So how to implement the double-ended queue? Here, in case of double-ended queue, in case of double-ended queue, we are using this structure. First, let this is the left link. Okay. Next, let this is your data part. Okay. Next, this is your priority part. Okay. Depending upon your priority, you have to insert and delete. Okay. And this is your write link. Okay. So this is the actually node structure. So how to define when you are declaring the C code, how to declare the node structure? Any idea? Any idea how to declare the node structure? Anyone?
Sir, there will be a previous pointer. There will
Previous
be
pointer
a
LL, then
yes, sir.
data. So return type of LL will be struct node,
Struct
then
node.
int data, then int priority. Okay, just priority means just a value. Okay, suppose priority a node with priority 5 is inserted before a node with priority 6. This is the priority queue. Okay, so int priority and struct node RL, struct node pointer RL. Is it clear? So let this is the just 1 second. A node number A. Let this is your first node A. Node number A and its priority is let 1. Okay. Then let this is your node number B. With priority number 2. Okay. Let we are using node number D with priority 3. And just 1 second, let this is your last one. Let this is your F with priority number 4. Last node. So last nodes.
Next part will be null.
Null.
Sir,
Yes.
can we not insert higher priority before a lower priority?
No.
Okay.
It's restricted. Okay.
Okay, sir.
So first 2 to oh sorry 1 to 2, then 2 to 3, 3 to 4. Okay. Then from 4 to 3, 3 to 2, and 2 to 1. Is it clear? And this is null. So this is the priority queue. Now how to insert? Now how to insert? Let H. Let H with the, let this is null initially with priority 10. How to insert? Any idea?
Sir, first we will check all the priorities,
Yes.
and if we encounter a higher priority than the one we are inserting, then we will use the insert before a particular node function.
Otherwise,
Otherwise, we will insert it at the end.
okay. So insert at the end. So first of all, let line number 1. Sorry. Line number 1, our PTR is equal to our pointer is head. Okay, header. Next, let new node is equal to, we are using the let the get node function. Get node function. What is the get node function? How to declare in case of C? Any idea? Yes, malloc. Malloc. So actually get node function. So actually this is the algorithmic implementation, line number 2. So this is your new node. This is your new node. New node. So new node is equal to new underscore node. Okay. So new node is equal to get node. That is using the malloc function. We have to declare the new node. Okay. Then what should we do? So let this is head. PTR is equal to head. Now we have to put the age. We have to put the age at the data portion of the new node, right? Is it clear? So new node, its data part is equal to your n. Is it clear? Now new node, its priority portion will be your P. Its priority portion will be your P. Now while your P arrow, sorry, your PTR, while your PTR arrow RL, while your PTR arrow RL not is equal to null. Why not is equal to null? Anyone?
Sir, we should not cross the last one. This is checking the last element.
And and your PTR and your PTR arrow priority and your PTR arrow priority is less than P. What should we do? Any idea? Anyone?
Uh, We should proceed to the
Yes,
next
we
one.
should proceed. Very good. So PTR is equal to PTR arrow here RL. Otherwise, next. You can also use next and previous instead of RL and LL respectively. So end while. End of the while loop. So while, and this is your and. So end of while. Now, so you are at the, so after the while loop, you are at the proper position. So if your priority is the highest, that is uh, suppose the list is empty or the n value is the largest priority value, then what will be the scenario? If your list is completely empty, or your n value is the n element number n with data part n has the highest priority value, that is your ptr, its right link
Will
equal
be
to is equal
null.
to null,
Null.
that is uh, list is empty, or your in that is item your item has the largest.
So for list equals to empty, PTR should be null. No?
For
For list is empty, PTR will be equal to null. No?
ptr is equal to null means ptr's next part is null. Your head has the following structures.
Yes, head has all these, but we are not initializing anything of head. Na? So maybe it may throw a error. I don't know.
Okay, so if there is a error, line number 8, for implementing the C, you have to use the ptr arrow, its next part, that is rl is equal to null. Okay, otherwise you can safely use ptr is equal to null. Your list is empty or your item has the largest priority. Then what should we do?
Then PTR equals to this new node.
Only ptr is equal to new node.
It's a head equals to new node.
It is equal to new node.
Yeah,
Your
like list is empty, so we have
actually new node, and your ptrs and your ptrs rl is equal to new node, and new node its its left position, the double linked list, its next position is equal to ptr. Okay, then new node's right position will be
null.
so new node's right position, this will be null. And next and next your rear is equal to new node, because your newly inserted node is now becoming the rear. Up to this, is it clear from line number 8 to 12?
Yes, sir. But if list is empty and we are initializing it, then head should also be initialized.
Head should
Head should also be initialized in case of empty list.
yes, then you can implement in your own way. Okay,
Yes, sir.
otherwise, that is if your ptr if your ptr its priority is greater than p, then what should we do? Any idea?
Insert before this
Yes,
particular
yes.
node.
Insert before. So this is insert before. So insert before. This is your homeworks. So insert before. How to insert before a priority list, before a given priority P.